More than 30 times farther from the Sun than Earth, hidden in the coldest shadows of the solar system, lies a planet we know surprisingly little about: Neptune. You can't see it with the naked eye, not even from the highest peaks under the clearest skies. It's too far, too dim, too alien. And yet what we do know about Neptune makes it one of the most mysterious worlds orbiting our Sun. It's the most distant planet, the least explored, and somehow the most chaotic. And here's the twist. On this frigid planet, one where sunlight takes 4 hours just to arrive, scientists believe there could be an ocean of superheated water deep beneath its layers.
How?
That's what we're diving into today. Along with its intense blue glow, its violent storms, its strangely structured rings, and the satellite that may have been stolen from the Kuiper Belt. Neptune is massive. It has a radius of over 15,000 miles and a volume large enough to fit 58 Earths inside. But it's not solid. There's no ground to stand on. Its surface is just the visible edge of a deep, dense atmosphere, and beneath that, a strange mix of water, ammonia, and methane ice wrapping around a rocky core. Despite being one of the coldest planets in the solar system, scientists believe Neptune might hide a searing secret. Inside, where pressure is immense and sunlight is a distant dream, there could be an ocean, not of regular water, but a kind of superionic water. A state of matter that behaves more like metal than liquid. That might sound contradictory. After all, Neptune's upper atmosphere hovers around -360 degrees Fahrenheit. So, where's the heat coming from? Unlike most planets, Neptune emits almost 3 times more energy than it receives from the Sun. That doesn't just make it strange. It makes it unique. Some believe it's internal heat, leftover energy from when the planet formed, or heat generated by slow gravitational compression. Others suggest a massive impact in the distant past may have supercharged its core. Then there's Triton, Neptune's largest moon. Some researchers wonder if gravitational interaction between the two bodies might be stirring things up from within. But not everyone agrees. In fact, some planetary scientists argue that the odds of a real, stable ocean existing inside Neptune right now are low, about 15%. They believe we may have to wait another billion years before the odds even reach 40%. Still, the planet's behavior keeps challenging our assumptions. Neptune's axial tilt is 28 degrees, almost the same as Earth's, which means it experiences seasons. But on Neptune, a single season lasts 40 Earth years. And one Neptunian year? 165 Earth years. But while the years crawl by, the days race. Neptune completes a full rotation in just 16 hours, and that speed stirs up a violent atmosphere. It's the fastest wind planet in the solar system. Some wind gusts there reach 1,200 miles per hour, 4 times faster than Jupiter's most powerful storms, and faster than the speed of sound on Earth. These furious winds sculpt a planet covered in massive cloud bands, violent tempests, and one particular feature that scientists still don't fully understand: a massive, swirling storm called the Great Dark Spot. This Earth-sized cyclone was first discovered in 1989 by Voyager 2. But when Hubble looked again just a few years later, it was gone. Instead, a new dark vortex appeared elsewhere on the planet. Unlike Jupiter's Great Red Spot, which has raged for over 300 years, Neptune's storms seem to come and go, typically lasting only a few years. And then something unexpected happened. In 2018, Hubble spotted another dark vortex. As expected, it started drifting toward the equator, which is usually where these storms break apart. But this time, it changed direction. It moved northward again. Even stranger, a small companion storm seemed to split off from the main one. That split might be part of the storm's death throes. But no one's ever observed it in real time like this before. And the storm's white companion clouds, which move even faster, remain just as much of a mystery. Scientists call them scooter clouds, and they're probably made of frozen methane. But Neptune isn't just wind and chaos. It also has something many forget: rings. In 2022, the James Webb Space Telescope snapped one of the most detailed infrared images of Neptune ever captured, revealing not just the planet, but also its delicate, ghostly rings and a surprising number of moons. These rings are incredibly faint. Unlike Saturn's icy halos, Neptune's rings are darker and dustier, made of tiny particles and clumps of unknown material. Some glow faintly, others nearly vanish against the dark. In the Webb image, we can see 5 primary rings. They're named after key astronomers who helped unlock Neptune's secrets: Gall, Leverrier, Lassell, Arago, and Adams. The Adams ring is the narrowest, just 35 kilometers wide, but it's also the most mysterious. It's laced with bright arcs, each with names like Liberté, Égalité, and Fraternité. These arcs aren't fixed. They shift. They exchange material. Sometimes they even change size. No one's sure why. Some scientists believe the arcs might be fragments from a broken moon, shredded by Neptune's gravity. Others think hidden shepherd moons, too small to see, are shaping them in real time. But as fascinating as the rings are, nothing compares to Neptune's most iconic satellite, Triton. When Webb turned its eye toward the icy planet, it didn't just see Neptune. It saw Triton glowing brighter than the planet itself.
Why?
Because Triton is almost entirely covered in nitrogen ice. It reflects about 70% of the sunlight it receives, turning it into a frozen mirror in the dark. Triton is larger than Pluto. It's more massive than all of Neptune's other moons combined. And it's cold. The surface temperature drops to -391 degrees Fahrenheit, the coldest of any known geologically active body in the solar system. And yet, somehow, Triton is still alive. Voyager 2 spotted it back in 1989. What it saw defied explanation. Geysers shooting plumes miles into the air. Cryovolcanoes. A surface pockmarked with strange, layered patterns and what looks like frozen lake beds. Some parts of Triton's surface are just 10 million years old. Others, maybe 100 million. That's incredibly young in cosmic terms, suggesting the moon is being reshaped from within. One theory? A subsurface ocean, insulated by ice and laced with ammonia, which keeps the water from freezing solid. The geysers may form when sunlight penetrates the icy crust, heats trapped nitrogen, and blasts it skyward. But there's a deeper implication here. Triton may be an ocean world. And there's something else. Triton doesn't rotate like other moons. It orbits Neptune backwards. That means it moves in the opposite direction of Neptune's rotation, a retrograde orbit. That's not just rare. It's unique among large moons. So how did it get that way? Most scientists agree. Triton didn't form with Neptune. It was captured, probably formed in the Kuiper Belt, and at some point got too close to Neptune. The ice giant's gravity pulled it in. And in the process, it may have obliterated other moons. Unlike Jupiter with its dozens of satellites, Neptune has far fewer. And it's likely that Triton is the reason why. Captured, disruptive, ancient, Triton is like a thief in orbit. And it may still be hiding secrets below its icy shell. The more we examine Triton, the more it seems to resist being just a moon. Its orbit, activity, brightness, and possible ocean beneath the surface make it feel like a planet that got kidnapped. If there's anywhere in the outer solar system where life might be clinging to some icy abyss, this could be it. But Triton's origins are a clue to something bigger, something about Neptune's own history. Because here's the twist. Neptune might not have formed where it is now. Today, it sits at the edge of the solar system. But planetary migration models suggest Neptune may have started much closer to the Sun. Early in the solar system's chaotic youth, gravitational interactions, especially with Jupiter and Saturn, may have flung Neptune outward, slingshotting it past Uranus and into its current orbit. That journey would have been disruptive. Neptune's gravity may have stirred up the Kuiper Belt, flinging some objects out of the solar system entirely and pulling others, like Triton, in. And speaking of the Kuiper Belt, Neptune is still influencing it. Many Kuiper Belt objects, KBOs, like Pluto, are in orbital resonance with Neptune. That means their orbits are locked in a precise pattern with the ice giant's motion. For example, Pluto completes 2 orbits around the Sun for every 3 that Neptune does. These resonances, are no accident. They're fingerprints of Neptune's past migration, its gravitational signature frozen into the architecture of the outer solar system. Some scientists even believe that without Neptune, the Kuiper belt might have collapsed or formed into another planet. Instead, Neptune's influence preserved it, shaped it, and possibly protected us from objects that could have otherwise wandered inward. But back to Neptune itself. Despite the Webb telescope's groundbreaking observations, we're still largely in the dark. We don't know what exactly lies inside Neptune. We don't know the full chemical composition of its core, or what gives rise to its intense internal heat. We don't know how its storms form, why they vanish, or how they behave beneath the visible layers. We don't even fully understand how ice giants like Neptune and Uranus form at all. These aren't just minor gaps in knowledge, they're foundational mysteries. And solving them could reshape our understanding not just of Neptune, but of the thousands of Neptune-sized exoplanets being discovered around other stars. That's right. Out there in the galaxy, Neptune is no outlier. In fact, ice giants are common. More common than gas giants like Jupiter or rocky worlds like Earth. They dominate exoplanet catalogs. If we don't understand Neptune, we don't understand the universe's most abundant kind of planet. That's why future missions to Neptune aren't just exciting, they're necessary. NASA and other space agencies are now discussing flyby missions or even orbiters that could dive deep into Neptune's atmosphere, study its rings up close, and investigate Triton's potential as a subsurface ocean world. A dedicated probe to Neptune could answer questions that have lingered for decades. It could unlock the story of Neptune's migration, confirm the existence of a hidden ocean, reveal the true dynamics of its rings, and capture high-resolution footage of those transient, world-sized storms. It could also explore Triton the way Cassini explored Saturn's moons, potentially identifying regions of cryovolcanic activity or subsurface heat. And it could help us prepare for the future, when we start exploring Neptune-sized exoplanets around distant stars, with telescopes like LUVOIR or HABEX peering through their atmospheres. But until then, we wait. We stare at that dim, distant blue dot and wonder. Neptune is more than just the last planet in our solar system. It's a window into everything we don't know about planetary formation, about atmospheric extremes, about gravitational chaos, and about the silent, ancient mechanisms that govern our cosmic neighborhood. It's beautiful, it's violent, it's cold, and it might be hiding oceans of burning water beneath its clouds of freezing methane. It might be a planet of secrets. Or it might just be the beginning of a story we haven't learned how to read yet. If you found this exploration of Neptune eye-opening, give the video a like. It helps us reach more curious minds. Subscribe for more deep dives into space, science, and mysteries beyond the horizon. And drop a comment. What do you think is Neptune's biggest secret? Could Triton hold life beneath its icy crust? Or is there something even stranger lurking in the dark blue shadows of the outer solar system? We'll be watching the skies.
See you next time.